Okay, so my name is Steve Muckle. I work at Google on kernel compliance testing mostly, but I dabble in scheduler stuff from my work in a past life. So I decided to do some work on EAS unit testing. It's an area that I see kind of is being underserved, so I'm going to talk a little bit about it, some of that work I've done in the last 6 months or so. So initially, I'll just sort of give some motivation for that, reasons why I think this is a problem. I'll talk about the resources I see out, existing tests in test suites from a survey I did, and then the work that I've done. So thinking back to at least sort of the beginnings of Android, CPU Freak is a really common source of customization. So I've seen that, to say, as sort of as long as I've been involved in Android, folks either creating their own governor or modifying existing CPU Freak governors. The scheduler has become, so especially with Big Little, it's really become a hotbed of customization. Google has an entirely custom load tracking system, but vendors typically make all sorts of hacks throughout the scheduler, either because of specific to their topology, hardware-specific things, or just performance and power optimizations that they find they want to do. And as part of Google, we would like to see these converge into sort of a single open source solution, but I don't know how possible or feasible that is. And with dynamic, I don't know if that's also going to make it harder, if we're going to see more sort of crazy custom hardware topologies. So when vendors make modifications in these areas, in my experience, they typically focus on high-level testing. So in the three major areas that I've listed here, perf, power, and UX, usually they're running, for power testing, they'll run a days of use type, some mixture of high-level use cases and do power consumption. For performance, there's, benchmarks like Geekbench or Antutu, and then UX, they'll collect jank measurements. Or other high-level numbers. So what's missing here, in my opinion, are low-level unit tests for the scheduler and for CPU Freak. So I'll give some examples here of, these are some issues that we've observed at Google, actual bugs that we've found. And these are the sorts of things that I would like to see validated by unit testing. I don't know that we really need to go in and discuss each one of these things in detail, but governor responsiveness is kind of an obvious thing. The wake-ups caused by schedutil. So if your CPU Freak governor is constantly, threads in that governor are constantly waking up, this is obviously going to be a power problem. The way that schedutil.gov is implemented, so it's collecting CPU utilization values from all the different CPUs. However, every CPU is not always updating those values. So if a CPU goes into some deep idle state, its last utilization value is going to become stale. And so there will become a point where you don't want to consider that anymore in your calculations. There was an issue where the governor was not sort of ignoring stale values. And that obviously causes problems. The wake-up path in the scheduler, so especially with Big Little now, the wake-up path is getting very complicated. There's all sorts of knobs, and it's very sensitive to things like what CPU you start the search for the best CPU for a particular task that's waking up. Where do you start that search in the CPUs that are available? And so we saw like an issue, I think, where the start CPU was wrong. And so this is important for a hot path like that. It's important to start at the right place, both so that you arrive at the correct answer, but also the latency for that calculation to be done. The sync flag, sync flag is very important in Android. So for Binder, this is a flag that you set like when a task is waking up. If the sync flag is set, then the scheduler knows that task is going to be going to sleep soon, and so that the waking task could be put on the same CPU. It's an important performance enhancement. And so this is something that really should be tested. At least there should be a test available. Whether it can be a compliance thing or not, we have to figure that out. But right now there is no verification of that, and so it's just we're getting bad performance. Some vendor complains about their bad performance, and a bunch of debugging later we find that they changed something in the scheduler and their sync flag is not behaving properly. The overutilized flag is a part of EAS implementation that was a more minor thing, but we found an issue with that. And then again, this is sort of low-level scheduler details, but the bias to the prev CPU of a task when it wakes up, we found issues with that being incorrect. So what are the existing resources out there that can help to verify these things? So I looked at a few different test suites. So rt-tests.git, this comes from the real-time Linux project. Most of these things are fairly high level and generic. They're not deep, sort of specific enough to target the kinds of issues that I was concerned about. Hackbench is just, that's not even really a test. It's just sort of a general stress generator. Yeah, so these are not really getting at the, so you've got some things concerned with signal latency or testing the latency of other scheduler primitives. I mean, they're useful, and I do think that we should probably be seeing more vendors running these things, but they don't completely fill the void that I was concerned about. So LTP is kind of a similar thing. It's probably more broad in terms of the things that it covers. Again, so at the top, it has some things concerned with testing sort of high-level scheduler primitives. There's a few things that verify specific bug fixes that were created. So, unit tests for particular bugs. More general stress tests that don't actually return sort of a result. This is just something you run, and if things don't die, then you passed. The biggest thing in LTP is syscall testing, so there's good coverage for all the syscalls, so that's there. And then the power management tests, those are very broad. So the basic CPU freak test, that does things like just try and go to every frequency that it finds in sysfs, try to go to every governor, confirm that some sysfs nodes are present. So again, not really the depth that I'm concerned about. And then k-self-test is pretty minimal. I mean, if whoever's familiar with k-self-test, it's really just sort of a smattering of coverage across some random areas of the kernel. There really is nothing for the scheduler itself. It has some stuff for CPU freak, but it's also fairly minimal. Again, going to different governors. I think it's really designed to test the locking in the CPU freak framework, rather than going into detail of like a specific governor like schedutil. So. Getting to, and then, sorry, this last but certainly not least, so Lisa. So this is something that Chris could probably talk in more detail about. But this actually does, this goes to great length. This is like purpose-built for exactly what I'm concerned about here. So, it has great tests for EAS placement, load tracking. So it's developed and maintained by ARM, really for this exact sort of thing. Lots of powerful analysis tools. My personal issue with it, and this is certainly something for debate and would be a great topic for discussion here, is I guess whether it's too heavyweight to really fill the need that I see for sort of quick tests that can be run in a test suite that has broader exposure, like LTP. It's fairly large. It's got multiple projects to run the whole thing. It's got an integrated test runner. It's heavily reliant on Python. So if you're, like I'm not a real Python master, I'm much more comfortable with C. So that limits my ability to use a lot of Lisa's functionality. And it has its own shell, which is not really here or there, but it just kind of a, comment on its size and complexity. So. But this is kind of, I think this is the big thing that if we are to create new tests, this is sort of the gold standard, I think, in terms of, for one thing, making sure that ARM is comfortable with what we're creating and reaching a parity of features. And, we want to make sure that tests give the same result. In the case that we have tests that mirror what's in Lisa, they obviously need to give the same result. So, what I've done is created a small initial set of C-based tests. My thinking was that these would go into LTP, so I've written them to be compliant with LTP's design standards. It functions by enabling tracing and then parsing the trace. So in order to parse the trace, I've written my own trace parsing library, which is kind of gross. In the future, I'd like to try and utilize, so I'm aware of an effort with trace command to turn, I think it's called libtrace, I forget, I think it's in my future work slide, but they're trying to make a proper library out of that, and so it would be nice to use that instead. So this initial set of tests that I'm about to describe is merged into AOSP's fork of LTP, so you can go and check it out. The link to the commit is there, and you can have a look at it and try it. So the test that are currently implemented. So I just gratuitously grabbed what was in Lisa for these and just wrote my own version of it in C. So the EAS task placement tests are there. They're all pretty self-explanatory. And I'll talk more, I guess, about the functionality. So I have some results for a couple of targets that I'll review in a moment. So for SCEDTune, I have a test that plays with the boost values, and then we can look at the utilization. So this relies on an out-of-tree trace point. I'm hoping, actually, that we can get that upstream. I think it's a pretty non-controversial trace point, but basically makes sure that the task utilization is consistent with the boost manipulations that we're doing. And so this is a new test. And then a couple of tests for the schedutil governor. So I starred these because these actually are applicable to two of the issues that we found, within the last year or so. So this would check a couple of boxes for us in terms of known problems, making sure that the latency of the governor is reasonable. So this is, like spinning up a CPU hog task, making sure that the governor goes to fmax within a reasonable amount of time, and then just making a small task, make sure we go to fmin, and then checking the number of wake-ups from the governor threads to see that they're reasonable. And then some generic scheduler tests. This is stuff that's applicable to really any platform. Creating a handful of CFS tasks, pinning them to a single CPU, with different priorities, making sure that their bandwidth works out. So, if you look at fair.c or whatever, you can figure out what the bandwidth should be based on the different NICE levels, make sure they get the correct amount of runtime, checking the deadline task execution correctness, so both runtime and deadlines. I'm not aware, so in the real-time test suite, I didn't see anything for this. I'm sure there's got to be something like this out there somewhere, but I didn't see it. Scheduling latency, there is a test in the real-time suite for RT, but not for deadline. That I saw, and then the correct priority scheduling for both FIFO and round-robin RT tasks. Okay, so as I say, I've run through all these tests on both Pixel 3 with AOSP and then also the High-Key 960. So, sorry, there's a question. Yeah.
How did you take into account the C group impact on all your tests? I mean, running all these tests for RT, CFS, bandwidth allocation can be deeply impacted if you're using C group, CFS, bandwidth, C group in your test. Are you using it, or it's just a plain root task running?
So for the SCEDTune test where I play with the boost values?
The previous test list that you mentioned. Testing that the task bandwidth is affected by the CFS priority, running in a C group or at the root.
So these tasks should all be in the root C group.
Okay.
Yeah, because they're created just out of the shell, and so on Android that should put them all in the root C group. So. Okay. So these test results with Pixel 3. So I guess a couple of things up front. One thing is that a lot of these tests have thresholds. The notion of what's passing for a latency, for like up migration latency, or the percentage of, so for like EAS one small task, for example, the test criteria there is the task should run on the small CPUs of a big little topology for a certain percentage of time. What is that percentage? That's going to be dependent on who's running the test, right, and what your pass criteria is. So that's something that needs to be arrived at. So some of these failures are really just a matter of, do we have the right thresholds for the test, the percentage of correct task placement, or the right latency thresholds. So for Pixel 3, the up migration latency, I'd set that to 100 milliseconds. Pixel 3 is not meeting that. So the EAS small to big task, small to big test is failing consistently. That's probably a good thing for discussion. I don't recall what happened with the big to small test. Small big toggle, again, it's the migration latency that's killing that, so the small to big transition is consistently happening slow. And then EAS 2 big, 3 small, the small tasks are consistently running on big cores. And this is something that I see on you'll see it in the HiKey960 results as well. And in discussion with ARM, that's something that, so the ARM folks have graciously played with this as well and given me some results, and they're also seeing that. So I think this would be a good thing to look into. The latency, so the governor test looked pretty good. The sched boost failures, I think that's an issue again with the thresholds. So this is, again, we're playing with the boost tuning for a test C group and then seeing what the bandwidths look like, or the runtimes, or I'm sorry, the utilization values. And there needs to be some slack in the utilization values, and I'm not sure that that the slack is enough. Yeah, most of these results looked pretty good. I did see a couple of failures in the latency tests, and that's something that might deserve some looking into, where our latency to run a deadline or an RT task, I think it got up to like 150 microseconds, whereas normally it's down under 20. So it seems like, I don't know if it's an interrupt latency issue or what, but it probably should be looked into. So HiKey960, basic one small task test. We're just, I think, so the threshold for that is 90% is what I had set it at, and we're not meeting that. This is not a commercial, so one thing to keep in mind here, of course, HiKey960 is not a commercially tuned platform, right? So that's something to keep in mind with these numbers, and are we going to meet the same kind of thresholds that we can meet with a commercial target? I don't know. Small to big, not really passing, so we're getting too much small task runtime on the big cores when the task is small. Again, as I mentioned, the 2 big, 3 small tests not working very well. And then the maximum migration time we're seeing during the small to big toggle test is not good, over 100 milliseconds. The governor latency, this is a case where I think our threshold's probably just not good. Our latency is right around 70 milliseconds on HiKey960, and so it's not passing all of the time. I'm seeing a lot of wake-ups from the governor on HiKey960. And then lastly, the other major issue, this sched latency DL one on 960 is looking pretty bad. So the latency is consistently around 300 milliseconds, or I'm sorry, microseconds. I ran this twice actually and saw the same behavior both times. I did get one instance where it was down under 20. So this looks like there's some kind of system problem where our latency is not good. So future plans, I am hoping to get this upstream. I mean, I think there's a lot more work to do to make sure that this is supported on all topologies. We don't want to put this into LTP if it's going to cause confusion and be more trouble than it's worth. As I just went through, there's a number of existing failures. This is already generating leads on potential bugs on a couple of platforms. So there's already a good amount of work to do there. There are some tests that are flaky, some robustness issues. The upstreaming, I'm sure, is going to, so once we're confident that this test suite has value and is accurate, just going through the review process with the LTP folks, I'm sure it will generate more cleanup work. And then there's, out of all the existing problems I listed before, I think there's only 2 of them that are addressed with the tests that I just mentioned. And so, there's still work, especially the sync flag. We don't have a test for that. And some of these things get pretty difficult to verify with the unit tests. For example, the sync flag, I have another test in progress for verifying that the stale CPU utilization and the schedule governor is ignored. And that is not easy to implement. And then ideally, if we can get these tests reliable enough, we'd love to get them into VTS and turn them into a compliance requirement for partners. Will we get there? I don't know. We'll have to see. This is something that we really need more experience with on more platforms and see how reliable we can get these tests. And then, as I mentioned, it'd be great to ditch the custom trace library because I don't want to have to maintain that. So I think that's it. We have a few minutes for any questions. It's on.
Have you tried to run your LTP test on the mainline kernel now that we have this simple EAS patchet merge?
So I believe the ARM folks actually did that. I don't recall the results offhand. I do have them, and I can share them with you afterwards. So
yeah, that would be interesting.
I see one of the challenges for upstreaming your code to LTP. So you're specifying the latency depending on the hardware you're using. So if it's going to be upstream thing, then it has to be generic enough to identify the latency. So I have seen these cases with the TC2 and Juno when we are working with the Juno SCID test suite. So like these are configured per hardware to get the kind of a latency. Accordingly, take decisions to the verdict of a pass or failure. So how are you going to deal with this?
So yeah, there is a cleanup item too. So right now, as I mentioned, the two thresholds for like a lot of the EAS placement tests, the placement thresholds and also like up or down migration latency thresholds. Right now, those are just hard coded in the test. But I mean, at a minimum, we can pass those in on the command line, so folks can specify those in their own test scripts. I would also think that we should be able to arrive on some kind of really high threshold that's like a basic minimum for user experience. So for up migration latency, for example, if you have a small task that becomes large, I would think 200 milliseconds should be a pretty safe assumption that you should be able to get that onto the big CPU. Maybe not, I don't know. But I feel like we should be able to set some low thresholds that are as defaults and then be able to provide a way to override those if you want to tighten them up via the command line or whatever else.
These are specific to big LITTLE architecture only?
Some of them are. So like the EAS placement tests would be the general scheduler ones like deadline runtime and deadline verification. Those are more generic. So I had a set of maybe 6 tests that apply to all platforms. There's work to, I guess there's a few of them that will not run on an upstream kernel right now because they rely on out of tree EAS functionality. I'm not sure. The EAS ones also, ideally, they would be detecting the platform and return. So like in LTP, there's the tconf to skip, the test. They should do that, obviously, if there's functionality that's missing. I doubt that they do that right now. I don't remember off the top of my head. But that's a cleanup that we'll need to do as part of upstreaming. So,
thank you.
Sure. Any other questions? I think we're done. Cool. Thank you, everyone.